Eric Burgess here, and we have been given some data in a survey of 26 people who were asked their age, and then these are the results. Then they want us to do a bunch of stuff with this data. They want us to make a stem and leaf plot, a dot plot, a box plot, a left fence, a right fence, mean, median, mode, all of those kinds of things. So let's go ahead and dive right in. So first off, they ask us to make a stem and leaf plot. So a stem and leaf plot, the way it works is you draw a vertical line, and on one side is your stem. So this would be like the stem side, and this would be the leaf side. And then let's just start with our lowest numbers. So if we look at this, we see 27 that appears to be the lowest. So the stem of 27 is a 2, and the leaf is a 7. And then I'm going to go ahead and highlight it or underline it in red just so that we know we took care of 27. Also, while we're here, I highly recommend for problems like this to, while you do this, rewrite the numbers on the side in order from least to most. It's going to be often pretty handy to have. Your calculator can actually do this for you as well. In fact, instead of doing it by hand like this, let me show you the calculator way, because it's quite a bit better, and it also reduces error for this. So we're going to put this all in a list. So we're going to turn on the calculator, we're going to go to stat, and then we're going to go to edit. Now I have stuff in the list 1, so I'm going to come up, I'm going to hit clear, and then I'm going to push down, and it should clear your list. And then I'm just going to pull our numbers in. So we have 40, 55, 27, 60, 64, 66, 51, 47, 38, 50, 40, 60, 61, 65, 45, 10. Oh, I see. I totally missed 10. See, this is kind of why you want to do this. 32, 49, 32, 49, another 32, 52, 61, 52, 89, 31, 48, and 59. All right, so we've got 27 numbers in here, or we were on the 27th spot. So we have 26 numbers, and I like to go back and just double check. It's usually worth doing 52, 61, 52, 32, 49, 32, shirt 10, 45, 65, 61, 60, 40, 50, 38, 47, 51, 66, 64, 60, 27, 55, and 40. Also, if you can, sort of mumble them to yourself. I notice that when I say it out loud, I tend to make a lot fewer mistakes. So, okay, so we've got all our things in here. And now what we're going to do is we're going to go in and we're going to go again to stat. And then we can sort our list. So we're just going to hit 2 for sort. And we want to sort list 1. So list 1's here in blue. So we're going to hit the blue key and then list 1 and close the parenthesis. And so it says it has sorted list 1 for us. Now if we go back to our edit list, we'll notice that they are in order from least to most. So it put it in order for us. So let's go ahead and using this, let's make our stem and leaf plot. It's going to be a lot simpler than going through each one of the values individually. So first up, our first stem is a 1. So we put 1, and the leaf is a 0. The next one is 27. So since it has a different stem, it's not got a 1 as a stem, we put 2, and then the leaf is a 7. Then we have 31. That's another new one. So we put 3, 1. But then we notice that we've got a 32, and that also has the same stem. So what you actually do is you put a 2 next to it, and that takes care of that 32. And then we have another 2, so we put that next to it. So the way we would read the chart is we'd say there's a 31, there is a 32, and there is another 32. So that's how this chart kind of works. And now we've got 38, so we just add an 8, and that's it for there. coming down here. We've got 40, so we have 40, and then we've got another 40. Then we've got a 45. We've got a 47. Whoops. See, I put 47 there. We just need to write the 7 on the leaf part. 48. 49. Then we've got someone that's a 50. So we put 50. And then we've got 51. 52, 52, so 2, 2, and then a 5. We continue going, 59. And then we're on 60, so we have 60. Another 60, a 61. We asked a lot of old people. 61. I'm sorry if you're 60 and you don't think that's old, but just so you know, that's like in Jewish culture, it's like at 60 you're considered the age of an elder, I think is like the official age. So, I mean, I don't know. Other people think you're old. So, 66. And then we have 89. And that's it. Okay, so that is our stem and leaf plot all done. It takes a bit of time to get your data organized, but this would be helpful for later. Okay, so up next, they want us to make a box plot. So, a dot plot. So the way a dot plot works is we have a number line, and we start out at 10, and we got to go all the way up to 89, basically 90. So I'm going to make every 2 spots a gap of 10. So I'm going to start out at 10, and then we're going to go to 20, and then 30, and then 40, 50, and then 60, 70. See, this isn't even long enough. I want some room though, so I'm going to make this even longer. 70, 80, and then 90. All right, and for the box plot, all you got to do is simply put a dot for every time a number occurs. So there's a 10, so we put a dot right here. 1 dot. For 27, well, here's 20. We're closer to 30. We're past halfway, so 27's like right here-ish. And then we've got 31, so that's like right here. Then 32, and we've got another 32 is going to be closer to 31. And then we've got another 32, and then we've got a 38. Now we've got a 40, so that goes right on top of the 40, and another 40. We've got a 45, which is right there in the middle. 47, 48, and then 49. And then we've got a 50. Wow, just all crammed in there. 51, 52, another 52, 50. I'll make this more of a dot. 55, that's right there. 59. And we have a 60, another 60, 61, 61, 64, 65. So it's not the most I'm not doing the most accurate one in the world, but 66. It gets the job done. And then finally 89, which is close to 90. So you could get really accurate, and you could also write like the numbers above each dots. So you could clarify that, these are 52s above it, just to make it extra clear for whoever's reading it. But this is the dot plot. That's how you make a dot plot, and it's not too hard. You just gotta make some dots. Now this speaks to the distribution. So we see we're actually, of the people we asked, we're pretty spread out here. There wasn't anywhere that really got clumped up. Nothing's really super high above anything else. Also, while we're here, we need to write out an axis label. It's usually a good idea. So this axis represents the age of people. So this is age. And technically going up is the frequency, the number of people who have that age. But because it's a dot plot, we typically don't write this. But I highly recommend writing down the axis label. It's always a good idea to label your data. The dot plot takes care of the Y sort of for us. And we could do the same for the stem and leaf and write like stem and leaf for age. It's usually a good practice. All right, so next up, we've got make a box plot with a 5-number summary. So we just need our 5 numbers. So we say, okay, well, our lowest number, if we look at our stem and leaf, that was 10. And our highest number was 89. So our lowest number, well, that was 10. Highest was 89. And then for Q1, Q2, Q3, we need to figure out the middle of this. So to do that, what we're going to do is we're going to come up to our stem and leaf, and we're going to work our way down. And in fact, what I'm going to do real quick is I'm going to write out all the numbers again, because I think it's a little more visual. So bam, look at this. I've already got the numbers written out. And so here are all the numbers written out in order. And what we want is we want the middle number. So there's two cases for this. There's the case where two numbers appear to be in the middle, and then there's the case where a single number appears to be in the middle. And we're going to talk about both, but let's just do our case real quick. So in order to do this, what we need to do is we need to find the middle number here. So we just cross one off at the start and at the end. One at the start, one at the end. One at the start, one at the end. And we can go down the chain like this. And there's a way to do this more quickly. I'll show you, but I think visually it makes a lot of sense. One at the start, one at the end. One at the start, one at the end. One at the start, one at the end. And look at this. If we cross these two off, then there'll be no number in the middle. So this is a problem. And so we know 50 and 51. I'm going to go ahead and undo all our slashes because we're going to use these numbers for the next part. So 50 and 51, somewhere in the middle of these two is our median. And so what we would do is we would take our two numbers. We would take 50 plus 51 and divide by 2. And what you're going to get is you're going to get 50.5. So we get 50.5. And this is the case for our even, when we have an even number of numbers. So we have 26 numbers, and because of that, they evenly split into a lower set of 13 numbers and an upper set of 13 numbers that would go and swallow all of these. And because of this even split, we have to take the average of the two numbers that are here in the middle. So what you would do is you would count up to 13 numbers, and then you would take this one and the next one, and you would average them. That would be your median. So that's like the fast way to do it, just by taking the number of numbers you have, 26, and then dividing by 2. If you have an odd number of numbers, like if you had 27 numbers, well, there would be a number that is in the middle, and that number would be just past 50. And so you would actually take it, you would get 13.5, and so you would go to the 14th number, and that would be your median. So that's like the quick way to do it. So we see that our median Q2 is 50.5, and we can actually use the calculator for this as well. So if we go into our calculator, we go to stat, make sure your numbers are in a list, then go to calculate one variable statistics and hit enter, choose list 1, and hit enter, and it computes it for us. And if we scroll down some, we get our min, and look at this, it gives us Q1, Q2, which is the median, and Q3. And I believe it also gives us the, max. So it doesn't say low, it says max. So our Q1 is going to be 40 in this, but there we go, we get 50.5. You could check it using the calculator. If your teacher's chill with this, you can actually just run straight off this. But say your teacher's not chill, they want to see you like do the circles and everything. Well then, once we have our Q1, since there was no number that was exactly in the middle, we include the numbers when we find Q1 and Q3. So Q1 and Q3, so this is going to go like this and circle the lower half. Okay, so these numbers go with the lower half. I wrote them down there because of this black line. So, okay, now we want the middle of this first group, this group right here. We want the middle of this group, and we want the middle of this group. And we're going to do the exact same thing, but we're including the 50 and 51 since they weren't the exact middle. If you did have a number that was the exact middle, you would exclude it from the two groups. So that's how you deal with it if there was a number in the middle. So again, following our procedure from before, we do the crossing on the end, boom, 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 boom. One at the beginning, one at the end, one at the beginning, one at the end, one at the beginning, one at the end. And we see here 40 is indeed our Q1. So that's using the same procedure. Now for the second one, why don't we do it a bit differently? Let's do it the fast way. So we say, well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. So we take 13, divide it by 2. And 13 divided by 2 is going to be 6.5. We always round up because it's going to be just one number past. So the 7th number will be it. So here's number 1, 2, 3, 4, 5, 6, 7. So we see that 60 is going to be our Q3. And this agrees with the results on our calculator. And so there's sort of a bunch of ways to do it. Some teachers, they'll let you just go right to the calculator. Others are going to want to see you put in some effort and show your work. And so this is how you get the various numbers. Now, these numbers can be used to construct a box plot. And so we're going to construct the box plot before checking for outliers. But because that, I just happen to know that's usually how Citrus College teachers do it. But usually once you find your outliers, you exclude them from your data set and then you do it again. And 10 looks pretty suspiciously low. So that could be an outlier, but we'll find out after we find our fences. All right, now we need to construct the box plot. Now that we have our 5-number summary, but before we do so, usually we do so over an axis in order to show a proper scale, because scale with the box plot is kind of important because the box plot can point out how our data is skewed. So I'm going to copy the dot plot that we made earlier, and we're going to do it over this thing. So, okay, here's the dot plot. And we just simply start by plotting our 5-number summary. So our lowest value was 10. So over 10, I'm going to put a dot. I'm going to even write 10 above it. Now this marks the starting point of our data set. If we were to go 1/4 of the way through our data set, we would be at the first quartile. And that is the number 40. And if you think about it, here's where we started in our data set, right here. And we are going 1/4 of the way through, we would wind up at this 40. And so we're going to put over 40, we're going to put a line because we're going to make a series of boxes. So this is the 1/4 of the way through. And then if we go another 1/4 of the way through, we'd be halfway through. And that's going to be 50.5. Oh, I'm going to label this too. This is 40. So we're going to go to 50.5. It's going to be somewhere right around here. 50.5. And then we're going to go another 1/4 of the way through. We're going to get to 60. So that's going to be right around here. So that's 60. And then we're going to go to our highest value, which would be 100% of the way through our data, which is why there's no 4th quartile because that's just all the way through. So we just call it the high value. That is 89. And so that's going to be way up here. We're going to put a dot for that one. That's 89. And that's also why there's the first quartile. There's no like 0th quartile. It's just the starting point. That's why 10 and 89 are just considered the low and high values. So, okay, we draw a box using our lines in the middle. And this is the middle 50% of our data. And if they look similar, then our data is pretty symmetric. And so we're able to look at the skew. So if one side's really longer than another side, then we can see how the data is skewed because these are each representing 1/4 of our data. So using this, we want to detect if there's any outliers. So for this part, we're going to use the left and the right fence to determine outliers. So we're going to determine a fence. Any value lower than that fence is considered an outlier, and any value above that fence is considered an outlier. And outliers, the purpose of these fences is just to catch outliers. So this is where the middle of 50% of our data lives. And so values that are really far away from this are going to probably be outliers. And so we're going to say, okay, well, Q1, so that's 40, because we want to know our value's too low. So we're going to take 40, then we're going to subtract off 1.5 times the IQR, which is the interquartile range. So if this is very narrow, the interquartile range will be very small. And if it's very wide, the interquartile range will be a lot more forgiving because our data is more spread out. And so that's kind of the thought process behind this. So that's going to be the interquartile range is the difference in the 3rd quartile from the 1st quartile. It's this middle box. So that's going to be 60 minus 40. And that's going to tell us how long this box is. And so 60 minus 40 is 20. And then for the right fence, that's going to be 40 plus 1.5 times 20. Or my bad, not 40. Because we want to start at the third quartile and see if something's too high. So we're going to put 60 here, the third quartile. And if we look at our formula, that's what our formula has as well. So now when we plug these in, we're going to get our fence values. So let's grab our calculator. And that's going to be 40 minus 1.5 times 20. We get 10. We write that down. And then we do the same thing, but this time we have 60 plus. So we have 60, and then this is a plus sign. And we get 90. So we put our fences down, and we do so just by putting some parentheses on our box plot. So there's a fence here right at 10, and there's a fence right at 90. So 10 lands right on our fence, which is it's actually a pretty rare occurrence. So since it lands right on our fence, we're going to keep values that are only strictly less than, that are lower than this fence. So we're going to keep 10. We're not going to consider it an outlier, but you can make a pretty strong case for 10 being an outlier as well. So you're going to want to look at your study if you were doing some sort of a study and consider if this was like a legitimate value, because it could be. And then for 89, that lands barely within. So in this case, we don't have any outliers. But we've got our fences, and we are good to go. So next up, they want us to find the mean, and they want us to find the median. Well, we already found the median. Finding the median is easy. That was just 50.5. We've already done that. Now for the mean, that's all the values added together and then divided by the number of values. So if you were to do this by hand, you would add all of these values up, and then we have 26 numbers, and so you would divide that by 26. But in our calculator, we can go to calculate one variable statistics. You go to stats, calculate one variable statistics, and then we've already got our numbers in our list. And it's going to tell us that our mean right here is 49.38. So the mean, x bar, is 49.38. And we say x bar because it is a sample mean. And then also, we can also find the standard deviation. Now, you may need to use the formula depending on your teacher. So for the mean, if we were to use the formula, I didn't do it just because I think it's just like, it's a lot of writing. So, but you would add all of these things up. So if we were to do this, we would put in a fraction. So you hit the F1 key and then a fraction, and you do 10 plus 27 plus 31 plus on and on and on and on and on. So you have all your numbers, and then at the end, you would count all your numbers up. You know there's 26 already, and you would divide it. For the formula, you would have to do kind of a similar thing here. So we could get the standard deviation also from one variable statistics. If we just come in here and hit calculate, it tells us that's now there's two of them. It tells us that the standard deviation is 15.83. We know we need the sample standard deviation, which is S, because we have a sample of people. We don't have the population, so we can't use this one. And so when you go to look for the formula, you would have to look for the formula specifically for the sample standard deviation, not the population standard deviation. So we know from the calculator that S is equal to 15.83, but some instructors want you to show that you can calculate this by hand. Usually they put this at least once on your test, and they usually show this at least once on your test as well. And so for this, we would say, well, our n, that's equal to 26. Now for sigma x squared, we're going to have to take all the x values and square them and then add them all up. And then for sigma x, we're going to have to take all the x values, add them, and then square them. Okay? And then the bottom's already given to us. So for let's do the first couple. I'll show you how to compute the first couple, and then I'll let you go ahead and do like the entire column if you feel so inclined to do it by hand. So I'm going to clear this, and we're going to do this. So we've got x squared. Well, that's our first number is 10, so 10 squared is 100. And now we've got 27 squared. So we put 27, we square it, we get 729. And you would go on and you would do this for all of them. And then for the x column, you would just take 10, 27, and you just write all your numbers. At the end, you're going to add them. You're going to add them all up. You're going to get a number here. And you're going to add them all up. You're going to get a number here. Once you have these two numbers, this number is going to replace the sigma x squared. Because you've squared all the x values and you added them. This number, you're going to square first. You're going to square it. And then that will replace the sigma x squared. It's going to replace this thing right here. So you plug those two in, and then you plug in your n and your n times n minus 1, and you will get the standard deviation as well. In this case, it'd be an extremely long calculation by hand because there's 26 numbers. So I'm going to sort of cop out here and say, oh, well, we used the calculator. We know the calculator method. We're going to do that. If we had to do it by hand, we absolutely could. And if you're interested in seeing that in another video, I'd be happy to do that just as a separate video. If you have any questions about this, let me know. Subscribe. If you are a Citrus College student, feel free to stop by online tutoring, and we would be happy to help you out. And we'll catch you in the next problem.